Now that we've built the model, we need to establish the stand.
I hope this doesn't get blown way out of proportion.
To determine the ratio, we took the actual length and divided it by the model length. Once we found out that, we got for every 1 centimeter in the model, it was equal to 42.252 centimeters in the actual problem. This made our skid marks 7.065 meters, our height 31.9 meters, and our distance 13.098 meters.
Now that we've determined the length of the skid marks, we can see how fast he was going.
Patience, young one. I love the smell of kinematics anymore.
Now that we've determined the scale, we can calculate the time it takes for the 2 cars to fall to the bottom of the cliff using the second kinematic equation. We solved for the unknown and plugged in the variables, and we got a time of 2.552 seconds. Using this time, we could calculate the velocity that the 2 cars left the cliff using the equation for projectile motion. We solved it for velocity, then plugged in the numbers, and got 5.134 meters per second.
So now that we know the velocity just before they left the cliff, we can calculate the velocity of impact.
It's about time we put this stuff together.
Now that we know the final velocity of the collision, we can use that to solve for the inelastic collision. Since we know that's an inelastic collision, we can say that Pi is equal to Pf. We then plugged in the momentum of Chukrin and the momentum of Souza and set it equal to the momentum of both of them after the collision. We then solved for the velocity of Souza and plugged in our variables. With that, we got that the initial velocity of the collision of Souza was 10.299 meters per second.
Now that we know the velocity of Souza just before impact, we can use conservation of energy to calculate how fast he's moving before he applies the brakes.
Looks like Bruce isn't coming to play.
Now that we have the final velocity of Mr. Souza just before impact, we can calculate the initial velocity of Mr. Souza. The window was closed and Bruce did not come to play, therefore energy was conserved and the initial energy is equal to final energy. Therefore, the initial kinetic energy is equal to the final kinetic energy plus thermal energy from the tires and the skid marks. And we plugged in UKMG for FK, and then we solved for the initial velocity, and then we plugged in the numbers for the equation, and we got the initial velocity to be 14.506 meters per second. Then we converted it to miles per hour by multiplying it by 2.23694, and that came out to be 32.435 miles per hour.
Through the use of physics, the C.S.P. Francine physicists have concluded that on the morning of May 16th, Mr. Souza was driving his wife's 1953 Chevy 3100 because his man van was in the shop. As he approached the hairpin turn, he was distracted by the Cosmo magazine that he was reading. He was also going 32.4 miles per hour, which is 12.4 miles per hour over the regulated 20 mile per hour speed limit. He then braked for 7.065 meters before hitting Mr. Chucklin's Jeep off a 31.9 meter high cliff and launching him 13.1 meters from the base of the cliff.
Oh, looks like that's a wrap.
Looks like we've got this one in the bag.